In this question, we have to calculate the charges on each of the four capacitors. Now, as I told you in earlier question that when a capacitor is connected to a DC source, then they will act as an open switch. That is, no current will flow through the capacitor. So whatever the current is flowing out of the battery, let's say it will be divided in these two branches, but no current will be flowing through the capacitors. That is, this whole current will be diverted toward 1 ohm, that will be transferred to 2 ohm and back over here and here. Similarly, in this part, the current that is coming downward will be diverted to 3 ohm and no current will flow through the capacitor. So what I can say is, this 1 ohm and 2 ohm are in series, this 3 ohm and 3 ohm are in series. So I can calculate directly the current that is flowing in each of the branch. Let this current is I1, this current be I2. So I have 1 ohm and 2 ohm in series. Let's say the equivalent of both of them is R equivalent dash, that is 1 plus 2, that is 3 ohm. So current I1 can be calculated by the formula V by R equivalent dash, because the potential difference across the both point is 6 volt. So I have 6 divided by 3, that is 2 ampere. So 2 ampere is current going in the upper branch. Similarly, to calculate the value of I2, we calculate R equivalent double dash, that is 3 plus 3 comes out to be 6 ohm. So I2 is equals to V divided by R equivalent double dash, that comes out to be 6 divided by 6, that is 1 ampere. I2 comes out to be 1 ampere. Now I have to calculate the potential drop across 1 ohm, 2 ohm, 3 ohm and 3 ohm. So potential drop across 1 ohm is calculated by IR. Here I is R1, resistance is obviously 1 ohm, so I have 2 into 1, that is 2 volt. Potential drop across 2 ohm is I1 into R, that is again current is 2 into resistance is 2, that is 4 volt. Now I have the voltage drop across 1 ohm resistor. This will be the potential drop across the capacitor 1 microfarad, because both are in parallel, so the potential difference across them will be also same. So I will use the formula Q is equals to CV. Capacitance is 1 microfarad, potential is 2 volt. So charge on 1 microfarad comes out to be 2 microcoulomb. Here again I use the same formula, that is to calculate the charge on 2 microfarad capacitor. I have capacitance is 2 into 10 to the minus 6 farad. Voltage drop is 4 volt. So charge on 2 microfarad comes out to be 8 microcoulomb. Similarly, I will calculate the potential drop across this 3 ohm and this 3 ohm resistor. So potential drop across 3 ohm resistor is I2 into resistance, that is 1 into 3, comes out to be 3 volt. So the charge that I have to calculate on 3 microfarad capacitor can be calculated by formula C into V. C is given as 3 microfarad and potential is 3 volt. So Q across 3 microfarad comes out to be 9 microcoulomb. And to calculate the charge on 4 microfarad, obviously 3 volt is dropped across the 3 ohm resistor, remaining voltage will drop across another 3 volt resistor. So the voltage drop across this 3 ohm resistor is also 3 volt. So I will again use the formula Q is equals to CV. The capacitance is 4 microfarad, voltage is 3 volt, which gives the answer as 12 microcoulomb. That is our answer.